So in this problem, we're trying to find the volume of the solid of revolution created with these functions. You can do this one of two ways. This function, because it is not set already equal to x or y over here, you can do it with either the disk method or the shell method, and it's about the same. Reasonable. But you will see that instead of a number, this is not a 9, this is an a to the 1/2, and our axis of revolution is x equals a. So we're going to have to do some fun stuff with that in order to solve this problem, and let's get started. So with this not being in terms of one variable or another, we need to do that, and we need to decide which method we want to use. Continuing with the theme, I'm going to go with the shell method this time, and I will do a video on the disk method as well after this. So in order to use the shell method, we need two functions and our axis of revolution to be set to the same variable. Axis of revolution is x, and so we need two functions set equal to x, or in terms of x, I should say. So here we can say this is x equals 0. That's g of y equals 0, because there are 0 y's. If there were 1 y, so it would be x equals y. We could say g of y equals y, but because it's 0, g of y equals 0, and h of x equals 0. It's a little counterintuitive. And then for this one, we need to solve in terms of 1. So now we have x, and we need this one to be in the form f of x. And we can do that by solving for y, just like here. So what we're going to do is we're going to subtract x to the 1/2. In this problem, we're going to have to do a little algebra before we can even start the calculus. So subtract x to the 1/2 and then square it to get y equals a to the 1/2 minus x to the 1/2 squared. I'm just going to leave it like that because it's going to be easier to deal with for a little while. And then we can now say f of x equals this. Now then, we have our three functions that we need to do the shell method. So, of course, the first step we're going to have to do is we're going to have to take this function and set it equal to this function. This function is 0. So we're going to say f of x equals h of x. F of x is this, a to the 1/2 minus x to the 1/2 squared equals 0. Because it's equal to 0, it's pretty easy. We just square both sides. 0 squared is still 0. And then add x to the 1/2 over. So you have x to the 1/2 equals a to the 1/2. And then square both sides again, and you get x equals a. But over here, that's only one side of our domain. We need the other side. But if you look up here, we have g of y equals 0. Well, what is this? This is just x equals 0. So we can rewrite that right here. So we converted it from x equals 0 to g of y equals 0, just so we have everything in terms of, function notation. And then we can convert it back to x equals 0. And this will give us our domain. This is going to be the upper bound, and this is going to be the lower bound. And it's the upper bound because I'm defining a as positive. A is greater than 0 here because it can't be equal to 0, because our volume would be non-existent, because you can't take the volume of a two-dimensional object, which would be what that would be. If you're integrating from 0 to 0, it's just always going to be 0. There is no volume there. And so I said a is greater than 0 and x on this interval. Now, to do what we did before, which was find some c value inside here, we could just choose a number. But because we don't know what a is, we can't just choose a number. So we're going to have to express this in terms of a. And you can't say something like a minus 1, which would seem a little natural. But you can't say that because if a is 1 or less than 1, so if a is less than or equal to 1, then subtracting 1 from that would get you either 0 or a negative number, which was not in our domain. And so the way that we're going to have to express this is, the easiest way would be the average of these two numbers, and it would work even if this was some other number besides 0. So what we're going to do is we're going to add 0 and a and divide by 2. Just take the average of it. So 0 plus a here. 0 plus a is just a, and then divide by 2. So our c is a over 2, and this is guaranteed to be in this interval, no matter what our value of a is, as long as a is positive. So from here, we're going to, just like we did before, take our c value and plug it into f of x. So our f of x was a to the 1/2 minus x to the 1/2 squared. So we have a to the 1/2 minus a over 2 to the 1/2 squared. And from there, I went ahead and distributed this 1/2, so it's a to the 1/2 over 2 to the 1/2, and 2 to the 1/2 is just the same thing as square root of 2. So I have a to the 1/2 minus a to the 1/2 over square root 2 squared. And to do anything with this, I want to find a common denominator, which is square root of 2. So I'm going to multiply square root of 2 over here to get square root of 2 a to the 1/2 minus a to the 1/2 over square root of 2 squared. Okay, now from here, I ran out of room, so we're going to move down a couple lines. Now that we're here, we can factor out an a to the 1/2 out of this numerator. So I have a to the 1/2, and the coefficients here are square root of 2 and -1. So I have a to the 1/2 times square root of 2 minus 1 over square root of 2 and all that squared. Now that we have all of this settled, we can go ahead and distribute the squared. So a to the 1/2 squared is a. Square root of 2 minus 1 squared is just square root of 2 minus 1 squared. I didn't write that. Over square root of 2 squared is 2. Now, we could find some terrible number for this, but if we know, if we use a little bit of logic at this point, then we can say, well, square root of 2 has to be greater than 1, because anything less than 1 that gets squared will be less than 1. And since 2 is greater than 1, its square root must therefore be greater than 1. And actually, square root of 2 is my personal favorite number. It's 1.41421356237 approximately. And so that number minus 1 is going to be a positive number. And since we defined a as a positive number and 2 is a positive number, there's no way this number could be negative. And so instead of finding some terrible number here, I'm just going to generalize and say that f of c is some positive value. Now, if I say this is only useful because h of c is 0. If we look back up, way up here, h of x is 0, meaning h of any x value will be 0. So any positive number is greater than 0, which is why it didn't really matter what this number turned out to be. So I can say that f of c is greater than h of c, meaning that f of x is greater than h of x on this interval of 0 less than x less than a. Okay, continuing. Now that I have my f of x is greater than h of x, what we can do now is we can set up our integral. So everything before that was just prep. So now we have the shell method formula, which is our volume, equals 2 pi times the definite integral from 0 to a, because that was our domain. And then if we look back, I'll flip over. The whole reason I paused the video is I didn't have to flip over. But if we flip back, we look at our axis of rotation is x equals a. So we're rotating around this vertical line where x is equal to some a value. And if we flip back over, we can see that because a is not 0, I defined a as positive, then instead of just putting x, we have to put a minus x, because a is some value other than 0. And over here, because f of x is greater than h of x, we subtract it like this. And so this is the general formula. I'm just going to plug in my f of x here and my h of x here, but h of x is 0, so this is, again, just a formality. It doesn't really need to be there. I just wanted to make sure everything was accounted for. And so when I come down again, here I'm going to factor out a -1 because I want to have this x first and positive, and to put it first and positive, I have to factor out a -1. So that's what I did. So I have negative 2 pi times the definite integral from 0 to a of x minus a, not a minus x, but x minus a, and this kind of looks like an alpha, but that's an x. And then I also squared this out and forgot the 0, because the 0 doesn't matter. So a squared is a times 2 times them together, so you have negative x to the 1/2 times a to the 1/2 times 2, so you have negative 2 a 1/2 x 1/2, and then negative x to the 1/2 squared is positive x dx. From here, I just took a step to reorder this so that I have x in the front, and then this in the middle, and then a in the behind, so in order of my exponents. And I do this just because it makes me more comfortable. It doesn't actually change the value of anything. So if we continue on from here, I went ahead and distributed, and it gets a little messy. So we have x times x is x squared. X times negative 2 a to the 1/2 x to the 1/2. Well, this is a to the 1. And if we multiply it by this, then this x to the 1/2 and this x to the 1 become x to the 3 halves, because this is x to the 2 halves, and we multiply, add exponents. So you have negative 2a to the 1/2 x to the 3 halves plus plus x times a, so plus ax minus ax. So these are just going to cancel here in the next line. But then you have negative 2, so it's going to be positive. And it's the exact same thing we just did, except instead of the x is going to be the a. So we have the a to the 1 and the a to the 1/2 make a to the 3 halves, and then the x to the 1/2 remains. And then negative a times a is negative a squared dx. So that was something. Going forward, the first thing we can do is just cancel those away, and that's all I did here. Nothing exciting. But now we can integrate, because this is as good a form as we can get it to integrate. So I have x squared, integral of x squared is x cubed over 3. Now here you have to remember that a is just a number. It's not a variable, so we can treat it like a coefficient, because that's what it is. So we have x to the 3 halves, and the integral of that, well, the 2 is going to be on top. So you have 2 times 2 is 4. Increase this by 1, so this is x to the 5 halves over 5. So I have 4a 1/2 x 5/2 over 5. Then we're going to do the same thing over here, plus 2 times 2 is 4. 1 plus 2 is 3 over 3. A to the 3 halves, x to the 3 halves, then minus a squared x, and evaluated from 0 to a. So from here, we're going to factor out a 15 in the denominator. Move this down. Factor out a 15 in the denominator just to have everything nice and pretty when we plug on our numbers. But you could plug in your numbers now at any time. You could even, anyway. What we're going to do is, because this is x cubed over 3, and the common denominator is 15, 5 and 3, and 3 is just 15, we're going to have to multiply this by 5, because it already has a 3, it needs a 5, so we're going to 5x cubed. This one has a 5, it needs a 3, minus 12, 4 times 3 is 12, a to the 1/2, x to the 5 halves, plus, this has a 3, it needs a 5, 5 times 4 is 20, a to 3 halves, x to 3 halves, minus, this has nothing, so it needs both a 5 and a 3, so it needs an entire 15 a squared x, and still evaluated from 0 to a. From here, we can factor out a single x, because that is our lowest power here. So I have x, and then it's just decrementing each of these exponents by 1. Not too crazy. And then from here, it's really nice having this x out front, because you're integrating from 0 to a, and so when you integrate this equals 0, that entire term cancels away. So all you have to do is plug in a for this and simplify. So if we do that, if we plug in a here, then we have 5a squared minus 12a 1/2 a to the 3 halves plus 20a 3 halves a to the 1/2 minus 15a squared. Okay, this looks crazy, but it will simplify very nicely if we give it a moment. We have, again, this negative 2 pi over 15 just hangs out front the entire time. And now, if we look, we have negative 15a squared and positive 5a squared. So I'm just going to go ahead and combine those to negative 10a squared. But then, if we look at these, if we multiply a to the 1/2 by a to the 3 halves, well, that's just a squared, because you're adding exponents here, and 3 halves plus 1/2 is 4 halves is 2. So negative 12a squared, and again, 3 halves, 1/2 makes squared, so 20a squared. So now we have negative 10a squared minus 12a squared plus 20a squared, all times a, and all times this negative 2 pi over 15. Ooh. So from here, I'm sorry, I had to use another piece of paper. This one was a long one, a doozy. So from here, if you have negative 10 and negative 12, that's negative 22a squared. Plus 20a squared is just negative 2a squared, and then you have your a out here, and your negative 2 pi over 15 right there. So we can just go ahead and simplify this in a single step. I'm sorry that it's pulsating, it shouldn't do that. So you have negatives, so that's going to become positive. You have 2 times 2 is 4, and a times a squared is a cubed. So you're going to have positive 4a cubed pi over 15, and that is the answer. Whew. What a question. And then you get to see it all again during the disk method. I bet you're excited.